Hi, my name is David Hoffman, and I'm the senior instructor here at Beaumont Technologies, and I'd like to give you a little bit of breakdown about our course offerings through our Plastics Professional Series. Now, more specifically, we're getting into each specific course. We got our Mold Startup and Debug course. Okay, this one again teaches through mold startup procedures, mold bench test procedures, and also what we call our flow grouping methodology. Okay, we have map a mold by flow groups, and it really gives you a different way of looking at your data. Its foundation here is based on laminar flow principles and pressure drop principles of plastics. And by doing that and looking at your data a little differently, you're going to see a lot of things come out, and it's like somebody's going to turn a light on and your data is going to start to make sense to you rather than this random thought process of, well, geez, everything's random. Okay, well, in fact, maybe it's not. Maybe what you thought was random isn't so random after all. And this course will help you dive into your mold data, whether it's short shot data, mold maintenance data, or part quality data, and look at it a little differently from the plastics perspective. Our hot and cold runner systems. Okay, this course gets into the details of selecting gate locations and understanding part design. And once you have the part design, you can select a gate location. Once you have a gate location selected, you got to choose a melt delivery system. Am I going to use a hot runner or a cold runner? And once you choose that, how are you going to lay it out? And once you have it laid out, how do you size things? And once you have everything sized, what are some of those details that we sometimes put into the mold design that are designed to create variations? Well, we want to teach you and educate you about those things so that you don't put those into your mold designs. Injection molding and root cause analysis for QC and QA. Okay, this course specifically designed for those involved in quality control to educate them more about plastics, how plastics flow, the injection molding process. We take them out to our lab, we go through some molding practices, we collect some data, we come back into the course and we look at the data. Again, we're looking at it here from the plastics perspective, also incorporating our flow grouping diagnostics into this course as well, so that they can look at their part quality data, relate it back to the processor, who should also be looking at the data by flow grouping, and they can come to solutions quicker. Our shrink and warp course. This talks very much in depth in regards to more on plastic flow and rheology and viscosity, and what happens when we push a plastic. How does it change? And what about the part design? How does that affect how the plastic wants to shrink and warp, and understanding relationships such as PVT, which is pressure, volume, temperature, and relating this information to a part design or a processing scenario and understanding pressure distribution within the cavity and temperature distribution and cooling and so on. So again, so that the user or the students can go through and look at a problem and put together a thought process as far as, okay, if I got a warped part, how am I going to fix it? How do I know what's causing the warp so that I can hopefully get to a root cause faster? The mold design for project engineers. Okay, this course is not going to teach somebody how to design a mold specifically. In particular, take an example, an unscrewing mold. Okay, but we're going to teach the basics of mold design. 2-plate mold, 3-plate mold, parting lines, shutoffs, cooling designs, melt delivery systems. So we talk about various systems of a mold in this course. And we focus on a key few areas that unfortunately in our industry seem to be often misunderstood or unappreciated, in particular the cooling system and the melt delivery system. And we give our students a little bit more insight into there and things to consider and watch out for in their mold designs. So when they're sitting down and reviewing a project, that hopefully they can pick out some of these things and eliminate downstream problems. Plastic flow and design essentials for mold makers and designers. Okay, again, we're not going to teach a mold maker or designer how to design and build a mold. Okay, hopefully they know how to do that, but what we want to provide is a little bit more insight in terms of how they manufacture that mold and the effect that something as simple as tolerance can have on how plastic flows through a mold and how that can create problems for the processor and the quality control department downstream. Give them ideas and strategies on gate locations and runner design and understanding pressure through the system and what pressure drop is. So give them a little bit more insight into the processing world and the plastics rheology. The course on understanding and applying flow simulation. Okay, for this one, You're not going to come out knowing how to run a mold flow program or Moldex or Sigma, but rather you're going to understand better what simulation is, how it can be used, maybe how it should not be used, but also some of the assumptions and limitations in the software. Because it is simulation, it's not going to solve all the problems. It's not going to be 100% accurate all the time. Okay? We want you to understand what it is, what you need to supply to the analyst to help improve the results that you're getting from the simulation. And also then how to take the simulation results and apply it to the shop floor. Or vice versa, if you're troubleshooting a problem, how to take what you know from the shop floor and apply it into the simulation. What we're doing with our clients also these days is helping them invest in the future. So they come to us and they say, boy, you got a nice selection of courses here, but we really don't know what we need to do. Can you help us develop a plan? And so we started working with them in developing an employee continuous education and training plan. And what they'll do is they'll send us key job functions. And we'll look at those job functions as if those people were working for us and say, okay, if this person's working for me, I'm going to give them a list of required courses that they have to take because they're going to be able to do their job better. Then if they want to continue their education, there's going to be some recommended courses, ones that maybe aren't as critical but would provide some additional insight into some things and just reinforce their learning process. We'll help determine the rotation schedule based on our in-class schedules or that are currently publicly available, or if we need to hold specific training courses that are closed to the public but open to their employees of their particular company. What they like about this is it helps them get their employees up to speed quicker, rather than relying on internal resources and draining that and saying, okay, you're going to go sit over here with this person for a few days and that person's already busy. Now he's got to sit and train this person what he knows about plastics and rheology and design and so on. Rather, they can come to here, get kind of removed from the day-to-day grind and kind of focus on this information for a few days and get up to speed quicker through this rotation program, and that'll help them become more efficient within their company faster than using the internal resources. Thank you for taking your time to listen, and hopefully you consider us as your company's partner for your continuing plastics education needs. For more information, please visit our website.